In computer science, declarative programming is a programming paradigm, a style of building the structure and elements of computer programs, that expresses the logic of a computation without describing its control flow. Many languages that apply this style attempt to minimize or eliminate side effects by describing what the program must accomplish in terms of the problem domain, rather than describe how to accomplish it as a sequence of the programming language primitives. This is in contrast with imperative programming, which implements algorithms in explicit steps. Declarative programming often considers programs as theories of a formal logic, and computations as deductions in that logic space. Declarative programming may greatly simplify writing parallel programs. Common declarative languages include those of database query languages, irregular expressions, logic programming, functional programming, and configuration management systems. Definition: declarative programming is often defined as any style of programming that is not imperative. A number of other common definitions exist that attempt to give the term a definition other than simply contrasting it with imperative programming. For example, a program that describes what computation should be performed and not how to compute it. Any programming language that lacks side effects. A language with a clear correspondence to mathematical logic. These definitions overlap substantially. Declarative programming contrasts with imperative and procedural programming. Declarative programming is a non-imperative style of programming in which programs describe their desired results without explicitly listing commands or steps that must be performed. Functional and logical programming languages are characterized by a declarative programming style. In logical programming languages, programs consist of logical statements, and the program executes by searching for proofs of the statements. In a pure functional language, such as Haskell, all functions are without side effects, and state changes are only represented as functions that transform the state, which is explicitly represented as a first-class object in the program. Although pure functional languages are non-imperative, they often provide a facility for describing the effect of a function as a series of steps. Other functional languages, such as Lisp, OCaml and Erlang, support a mixture of procedural and functional programming. Some logical programming languages, such as Prolog, and database query languages, such as SQL, while declarative in principle, also support a procedural style of programming. Subparadigms. Declarative programming is an umbrella term that includes a number of better-known programming paradigms. Constraint programming states relations between variables in the form of constraints that specify the properties of the target solution. The set of constraints is solved by giving a value to each variable so that the solution is consistent with the maximum number of constraints. Constraint programming often complements to other paradigms, functional, logical, or even imperative programming. Domain-specific languages. Well-known examples of declarative domain-specific languages include the YACC parser generator input language, the make-build specification language, Puppet's configuration management language, irregular expressions, and a subset of SQL. DSLs have the advantage of being useful while not necessarily needing to be Turing-complete, which makes it easier for a language to be purely declarative. Many markup languages such as HTML, MXML, XAML, XSLT or other user interface markup languages are often declarative. HTML, for example, only describes what should appear on a web page. It specifies control flow, neither rendering a page nor its possible interactions with the user. As of 2013 update, some software systems combine traditional user interface markup languages with declarative markup that defines what the back-end server systems should do to support the declared interface. Such systems, typically using a domain-specific XML namespace, may include abstractions of SQL database syntax or parameterized calls to web services using representational state transfer and SOAP. Functional programming, and in particular purely functional programming, attempts to minimize or eliminate side effects, and is therefore considered declarative. Most functional languages, such as Scheme, Clojure, Erlang, Haskell, OCaml, Standard ML and UnLambda, however, do permit side effects in practice. While functional languages typically do appear to specify how, a compiler for a purely functional programming language is free to extensively rewrite the operational behavior of a function, so long as the same result is returned for the same inputs. This can be used to, for example, make a function compute its result in parallel, or to perform substantial optimizations that a compiler may not be able to safely apply to a language with side effects. Hybrid languages make files, for example, specify dependencies in a declarative fashion, but include an imperative list of actions to take as well. Similarly, YACC specifies a context-free grammar declaratively, but includes code snippets from a host language, which is usually imperative. Logic programming languages such as Prolog state and query relations. The specifics of how these queries are answered is up to the implementation and its theorem prover, but typically take the form of some sort of unification. Like functional programming, many logic programming languages permit side effects, and as a result are not strictly declarative. Modeling models, or mathematical representations, of physical systems may be implemented in computer code that is declarative. The code contains a number of equations, not imperative assignments, that describe the behavioral relationships. When a model is expressed in this formalism, a computer is able to perform algebraic manipulations to best formulate the solution algorithm. The mathematical causality is typically imposed at the boundaries of the physical system, while the behavioral description of the system itself is declarative or acausal. Declarative modeling languages and environments include Analytica, Modelica and Simile.